Hello,
Hello,
am I
am I
audible?
audible?
Hello.
Hello.
Yes, sir. Audible.
Okay,
Okay, then
hello
hello
everyone.
everyone.
So
So
this
this
week
week we are going to
start with
start with
the
the
kinematics,
kinematics,
and
and
we will
we
be
will be
solving.
solving.
So
So
for
for
this
this
tutorial, we
tutorial,
will
we
be
will be
solving
solving
questions which
questions
are
which are
related
related
to
to
uh,
uh,
finding the
finding the
velocity,
velocity,
acceleration,
acceleration,
and
and
distance
distance
without
without
need to
need to
acknowledge the
acknowledge the
force.
force.
So
So
here
here
we
we
divided
divided
the
the
problem
problem
based
based
on
on
the
the
complexity
complexity
and
and
based on
based
the
on the
concept
concept
which
which
lies in
lies
the
in the
kinematics.
kinematics.
So
So
basically
basically
there
there
are
are
so
so
basically I
basically
have
I have
grouped the
grouped the
problems
problems
into three
into three
categories.
categories.
First
First
there will
there
be
will be
problem
problem
based
based
on
on
the
the
rectilinear
rectilinear
motion.
motion.
So
So
here
here
what
what
we will
we
see
will see
that
that
there will
there
be
will
a
be a
problems
problems
where we
where we
need to
need to
calculate the
calculate the
velocity and
velocity and
acceleration,
acceleration,
and the
and the
problem
problem
domain will
domain
be
will be
lie
lie
in
in
the
the
one
one
dimensional
dimensional
space.
space.
So
So
in
in
that
that
case
case,
the
the
vector
vector
notation
notation
can be
can be
simply
simply
expressed in
expressed in
terms of
terms of
their
their
signs,
signs,
and
and
we
we
we will
we
be
will be
concerned
concerned
only
only
about in
about
the
in the
one
one
direction,
direction.
that if
That
the
if the
body
body
moves in
moves
a
in a
single
single
direction,
direction,
what will
what will
be
be
its
its
acceleration or
acceleration or
distance, and
distance,
so
and
on.
so on.
Then
Then
there will
there
be a
will
few
be few
problems
problems
which
which
where the
where the
dimensionality is
dimensionality is
spanned
spanned
uh,
uh,
in
in
2D.
2D.
So
So
in
in
those
those
problems,
problems,
we will
we will
be
be
looking
looking
uh,
um,
or we
or
will
we
be
will be
calculating
calculating
these
these
quantities
quantities
like
like
velocity,
velocity,
acceleration
acceleration
in
in
x and
x
y
and y
plane,
plane,
or we
or
will
we
be
will be
using
using
the
the
path
path
variables
variables
like
like
the
the
normal
normal
vector or
vector
the
or the
tangential
tangential
vector,
vector,
and
and
then we
then
will
we
be
will be
solving the
solving the
problems by
problems by
using
using
those
those
path
path
variables.
variables.
And
And
then
then
there will
there
be
will
a
be a
problems
problems
where
where
we
we
concern
concern
about
about
rotational
rotational
motion,
motion,
where
where
instead of
instead of
calculating the
calculating the
linear
linear
or the
or the
translational
translational
acceleration or
acceleration or
velocity,
velocity,
we will
we
be
will be
actually
actually
studying the
studying the
motion
motion
in the
in the
curvilinear
curvilinear
coordinates
coordinates
or
or
in the
in the
polar
polar
coordinates.
coordinates.
So there
So
we
there
will
we
be
will be
calculating the
calculating the
angular
angular
velocity,
velocity,
angular
angular
acceleration,
acceleration,
and
and
these
this
class
class
of
of
problem we
problem
will
we
be
will be
studying by
studying by
assuming
assuming
that the
that the
acceleration
acceleration
will be
will be
constant,
constant.
and
And
for
for
these
these
cases we
cases,
will
we
be
will be
deriving
deriving
few
few
equation
equation,
and we
and
will
we
be
will be
using
using
those
those
equations
equations
straightforwardly.
straightforwardly.
But there
But
are
there are
some
some
class of
class of
problem which
problem which
requires
requires
that the
that the
acceleration
acceleration
is
is
not a
not a
constant,
constant,
and
and
there
there
we
we
need to
need to
simply
simply
uh, integrate the
integrate the
equation
equation
or
or
take the
take the
differentiation. We
differentiation.
will
We will
see
see
about
about
these
these
quantities,
quantities,
because
because
in these
in these
problems we
problems
are
we are
not
not
concerned
concerned
about the
about the
forces.
forces.
So
So
only we
only we
need
need
to
to
take
take
the
the
input
input
data which
data
is
which is
given in
given
terms
in
of
terms of
velocity or the
velocity or the
distance, and we
distance,
need
and
to
we need to
calculate the
calculate the
acceleration and so
acceleration and
on.
so on.
So
So
most in
most
some
in
of the
some of the
problem what
problem, what
happens that
happens
you
that
have
you have
given the
given the
acceleration
acceleration,
which
which
is
is
function of
function of
time or
time or
velocity,
velocity,
because
because
uh,
uh,
it
it
it may the
the
body may
body may
experience some
experience some
kind of a
kind of a
force,
force,
and due
and
to
due to
that
that
force
force
there will
there
be
will
a
be a
variable
variable
acceleration.
acceleration.
But
But
since
since
we are
we are
not
not
concerning
concerning
for
for
now
now
about the
about the
forces and
forces
all,
and all,
so
so
we have
we have
given the
given the
acceleration which
acceleration
is
which is
variable in
variable in
time and
time and
velocity,
velocity,
and
and
then we
then we
can
can
actually
actually
calculate the
calculate the
other
other
quantities
quantities
like
like
distance,
distance,
displacement,
displacement,
velocity,
velocity,
and so
and so
on by
on by
integrating the
integrating the
quantities.
quantities.
Whereas
Whereas
where
where
the
the
acceleration is
acceleration is
constant, we
constant,
will
we
be
will be
using
using
simply the
simply the
formula
formula
which
which
again
again
derived from
derived
the
from the
same
same
concept
concept
by
by
integration.
integration.
So
So
before
before
begin
begin
before we
before we
begin with the
begin with the
first
first
question,
question,
let's
let's
just
just
recap
recap
the
the
concept
concept
of a
of a
kinematics. So
kinematics. So
these are
these are
just a
just the
fundamental
fundamental
concept.
concept.
For example, let's say we have given a point O and there is a point P. Now the position of a point P can be given by the distance S, and let's say you move this point P to another point which is P dash, and then there will be a change in distance occur from point P to P dash. So the velocity will be given as limit of delta time tending to 0 divided by delta S and delta T. So this delta is the change of distance and delta T is the change of time. So we know that if in the limit of delta T approaching 0, the same identity will become ds by dt. And similarly, the acceleration will be given as limit delta t going to 0, and it is change in velocity by change in time, and at this limit we can simply write as d by dt or d square s by dt square. Now we will be using this above expression and we can write this expression as dv adt, and we can integrate this expression from time 0 to t and from velocity v naught to v. And when we do this, we will get v minus v naught equals at. So it will be v equals v naught plus at. So this is the first identity. Now similarly we can write v as ds by dt, and we can write this as ds equals v dt. So when we take the integration from s naught to s, and we can write v as v naught plus at dt from this identity 1, and we can integrate from 0 to t. So here we will get s equals s naught plus v naught t plus at square by 2. So this is the second identity where we have defined the relation between the distance s and acceleration and the initial velocity. And in the first equation we have defined the relation between v and the acceleration and time. Now if we take this expression and this expression and we remove this time derivative from these two expressions. For example, let's say I have ds, we have v equal ds by dt. I can write this as dt equals ds by v and a equals dv by dt, and I can write this as dt equals dv by a. So from these two expressions we will have ds by v, dv by a. So we can write this as v dv equal a ds. Now when we integrate this quantity, so we can get v square equals v naught square plus 2as. And if you integrate from s naught, let's say, here you will get s minus s naught. So these are the three identities which are valid only when the acceleration is constant.
And if
And
the
if the
acceleration is
acceleration is
not
not
constant,
constant,
then
then
instead of
instead of
using this
using this
identity,
identity,
just
just
simply
simply
integrate
integrate
the
the
variable.
variable.
Just
Just
simply
simply
integrate the
integrate the
variable
variable
to
to
uh,
uh,
get the
get the
unknown.
unknown.
So
So
integration is
integration
more
is more
powerful
powerful
because in
because
every
in every
case you
case
can
you can
integrate the
integrate the
variable to
variable to
get the
get the
unknown.
unknown.
But
But
in case
in
you have
case you have
a
a
constant
constant
acceleration
acceleration
given,
given,
you can
you can
save
save
time by
time by
using
using
these
these
identities.
identities.
This
This
equation
equation
1, 2,
1,
and
2,
3.
and 3.
So
So
let's
let's
move to
move
the
to the
move to
move to
the
the
first
first
question.
question.
So
So
here the
here the
velocity of a
velocity of a
particle
particle
which
which
moves
moves
along
along
the
the
s-axis is
s-axis is
given
given
by
by
v
v
equals 2
equals 2
minus
minus
40
40
plus
plus
5t to
5t
the
to the
power 3
power
by
3 by
2,
2,
where
where
t is
t
in
is in
seconds
seconds
and
and
v
v
is in
is in
meter per
meter per
second.
second.
Evaluate the
Evaluate the
position
position
s,
s,
velocity
velocity
v,
v,
and
and
acceleration
acceleration
a
a
when
when
time
time
t
t
equals
equals
3
3
seconds.
second.
The
The
particle
particle
is
is
at the
at the
position
position
s
s
naught
naught
3
3
meter
meter
when t
when t
equals
equals
0.
0.
So
So
basically we
basically,
have
we have
given the
given the
expression of
expression of
velocity
velocity,
and we
and we
need to
need to
calculate
calculate
the
the
position,
position,
velocity and
velocity, and
acceleration
acceleration
at
at
time
time
t
t
equals 3
equals 3
seconds.
seconds.
So
So
it's a
it's a
pretty
pretty
straightforward
straightforward
question.
question.
So we
So
have
we
given
have
the
given the
velocity 2
velocity 2
minus
minus
40
40
plus
plus
5t
5t
3 by
3 by
2,
2,
and we
and
need
we
to
need to
find the
find the
speed,
speed,
velocity and
velocity, and
acceleration
acceleration
at
at
time
time
equal to
equal to
3
3
seconds.
seconds.
And we
And
have
we have
given
given
that
that
at
at
time
time
equals
equals
0,
0,
the
the
initial
initial
position
position
is
is
3
3
meter.
meter.
So to
So to
calculate the
calculate the
velocity at
velocity at
time
time
equals 3
equals 3
seconds, we
seconds, we
just
just
need
need
to
to
substitute the
substitute the
value of
value of
t in
t
the
in the
expression
expression,
because we
because
are
we are
already
already
given
given
the
the
expression for
expression for
velocity
velocity
in
in
terms of
terms of
time.
time.
So if
So if
you
you
need to
need to
find the
find the
velocity at
velocity at
specific
specific
time,
time,
just
just
put the
put the
value of
value of
time
time
into the
into the
expression
expression
to
to
calculate the
calculate the
velocity at
velocity
that
at that
time.
time.
So
So
from the
from the
above
above
expression, we
expression, we
have
have
velocity
velocity
at
at
time
time
equals
equals
3
3
will be
will be
2
2
minus
minus
4
4
multiplied by
multiplied by
3,
3,
5
5
multiplied by
multiplied by
3,
3,
3 by
3
2.
by 2.
So when
So
we
when we
calculate
calculate
this,
this,
we will
we will
have
have
0.196
5.196
minus
minus
multiplied by
multiplied by
5
5
plus
plus
2
12
minus
minus
12.
12.
So it
So
will
it
be
will be
15.98
15.98
meter per
meter per
second.
second.
So
So
this is
this
my
is my
velocity
velocity
at
at
time
time
t
t
equals
equals
3.
3.
Now,
Now,
in
in
order to
order to
find the
find the
position
position
s,
s,
we can
we can
integrate the
integrate the
above
above
expression
expression
v
v
equals
equals
ds by
ds by
dt.
dt.
So we
So
will
we will
have
have
ds by
ds by
dt
dt
equals
equals
2
2
minus
minus
40
40
plus
plus
5t
5t
3 by
3 by
2 to the
to the
power 3
power
by
3 by
2.
2. So ds will be dt from 0 to t and the distance from 0 to s. So or s naught. Because we have given the initial distance at time t equals 0, so it will be s naught. So it will be s minus s naught equals 2t minus 4t square by 2 plus 5 t 5 by 2 5 by 2. This is from 0 to t. So I can simplify. So this s naught is 3. We have given in the question that at time t equal to 0, my initial position is 3 meter. So it will be s minus 3 equals 2t minus 2t square plus 2t 5 to the power 5 by 2. So my s will be 3 plus 2 multiply 3 minus 2 multiply 3 square plus 2 3 to the power 5 by 2. So it will be 3, 6, minus 18 plus 2 multiply 15.88 so it will be 22.76 meters. So this is the distance or the position sorry, at time equals 3. And similarly, we can calculate the acceleration. So it will be a and we have given the velocity 2 minus 4t plus 5t 3 by 2. So to calculate the acceleration, we just need to differentiate the velocity expression. So it will be a minus 4 plus 15 by 2 t 1 by 2. So acceleration at time t equals to 3 will be minus 4 plus 15 by 2 3 1 by 2. Four minus 4 plus 12.99. So acceleration at t equals 3 will be 8.99 meter per second square. Sorry. So this is my acceleration and this is my position and this is my velocity at time 3 t equals 3. So just to recap, we have given the expression for the velocity and we need to find the position, velocity and acceleration at time equals 3 seconds. So to find the velocity, we just put the expression of time here to get the velocity at a specific time. And to find the distance and acceleration, we actually use these quantities.
So to
So
find
to
the
find the
position here,
position
you
here,
need
you
to
need to
integrate
integrate
this
this
quantity,
quantity,
and to
and to
find the
find the
acceleration, you
acceleration,
need
you
to
need
take
to
the
take the
derivative of
derivative
the
of the
velocity here,
velocity here,
and
and
then
then
put
put
the
the
required
required
value of
value of
time
time
to
to
calculate the
calculate the
specific
specific
position
position
and
and
acceleration
acceleration
at
at
that
that
time.
time.
So
So
any
any
doubt
doubt
in this
in this
question?
question?
If not,
Not,
then we
then we
can
can
move
move
to
to
the
the
next
next
question.
question.
So in
So
this
in this
question, we
question,
have
we
given
have
a
given a
small
small
projectile
projectile
which is
which is
fired
fired
vertically
vertically
downward into a
downward into
fluid
a fluid
medium
medium
with
with
an
an
initial
initial
velocity of
velocity of
60
60
meter per
meter per
second.
second.
Due to the
Due to the
drag
drag
resistance of the
resistance of the
fluid,
fluid,
the
the
projectile
projectile
experiences a
experiences a
deceleration of
deceleration of
a
a
minus
minus
zero
zero
point
point
0.4
4
v
v
cube
cube
meter per
meter per
second
second
square,
square,
where
where
v
v
is in
is in
meter per
meter per
second.
second.
Determine
Determine
the
the
projectile
projectile
velocity
velocity
and
and
position
position
for
4
second
seconds
after
after
it
it
is
is
fired.
fired.
So
So
in this
in this
question, we
question,
have
we have
given the
given the
initial
initial
velocity,
velocity,
which is
which is
60
60
meter per
meter per
second, and
second,
we have
and we
given
have
the
given the
acceleration,
acceleration,
which
which
is
is
minus
minus
zero point 0.4
zero point 0.4
v
v
cube.
cube.
And
And
using this
using this
information, we
information,
need
we
to
need to
find the
find the
position and
position and
velocity
velocity
at
at
time
time
4
4
seconds.
seconds.
So
So
since we
since
have
we have
given the
given the
acceleration, we
acceleration, we
can
can
actually
actually
write
write
down
down
the
the
expression of
expression of
acceleration,
acceleration,
which
which
is
is
dv
dv
by
by
dt.
dt.
And
And
in
in
order to
order to
calculate the
calculate the
expression for
expression for
velocity,
velocity,
we
we
can
can
write
write
this
this
as
as
dv
dv
a
a
dt.
dt.
So it
It
will
will
be
be
dv
dv
minus
minus
zero point
zero point
0.4
4
v
v
cube
cube
dt.
dt.
So I
So
can
I can
further
further
simplify to
simplify to
dt
dt
equals
equals
dv
dv
minus
minus
zero point
zero point
0.4
4
by
by
v
v
cube.
cube.
So
So
now I
now
can
I can
integrate it
integrate it
from
from
0
0
to
to
t,
t,
and
and
here
here
from
from
v
v
naught
naught
to
to
v.
v.
We are
We are
given the
given the
value of
value
v
of v
naught,
naught,
which is
which is
60.
60.
So when
So
we
when we
integrate,
integrate,
we will
we will
get
get
t
t
equals
equals
1
1
by
by
v
v
square
square
from
from
60
60
to v.
to v.
So it
So
will
it will
be
be
0
0
0.8
point 0.8
1 by
1
v
by v
square
square
minus
minus
1 by
1 by
60
60
square.
square.
So
So
from this
from this
expression, we
expression, we
can
can
actually
actually
calculate
calculate
this
this
expression of
expression of
v.
v.
So we
So
can
we can
actually
actually
calculate this
calculate this
expression
expression
here.
here.
So we
So
will
we will
get
get
v
v
equals,
equals
so
so
zero point
zero point
0.8
8
t
t
equals
equals
1 by
1
v
by v
square
square
minus
minus
16
16
square.
square.
So it
So
will
it
be
will
1
be
by
1
v
by
square point 8
point
t
8 t
plus
plus
1
1
plus,
plus
sorry,
sorry
plus 1
plus
by
1 by
60
60
square.
square.
So
So
v,
V
or
or
v will
V
be
will be
1
1
plus
plus
60
60
square
square
plus zero
plus
point
point
0.8
8
t
t
to the
to the
power
power
1 by
1 by
2,
2
because
because
it's a
it's
v
a V
square.
square.
It
It
is,
is
so
so
earlier it
earlier
was
it
1
was
by
1
v
by V
square.
square.
So
So
first
first
I
I
uh,
uh,
reciprocate the
reciprocate the
expression to
expression
v
to V
square.
square.
So
So
it will
it will
become
become
inverse
inverse
at the
at the
RHS,
RHS.
and then
And then
I
I
pull
pull
out the
out the
root.
root.
So it will
It will
be,
be
it will
it will
become
become
the
the
power
power
minus 1
minus
by
1 by
2.
2.
So this
So
is
this
my
is my
expression for
expression for
velocity,
velocity.
and we
And we
need to
need to
find the
find the
velocity
velocity
at
at
time
time
t
t
equal
equal
4
4
seconds.
seconds.
So it
So
will
it
be
will
1
be
by
1 by
60
60
square
square
plus
plus
0.84
0.84
to the
to the
power
power
minus 1
minus
by
1
2.
by 2.
So the
So the
velocity at
velocity at
time t
time t
equals to
equals to
4
4
will be
will be
0.5589
0.5589
meter per
meter per
second.
second.
Now we
Now
need to
we need
find
to
the
find the
position.
position.
So we
So
can
we
write
can write
velocity
velocity
as
as
ds by
ds by
dt,
dt
and
and
ds will
ds
be
will
v
be v
dt.
dt.
So
So
this
this
ds will
ds
be
will be
1 by
1 by
60
60
square
square
plus
plus
zero point 0.8
0.8
t
t
dt.
dt.
And we
And
need
we
to
need to
integrate
integrate
this
this
from
from
0 to
0 to
s
s
and
and
from
from
0 to
0 to
t.
t.
So we
So
will
we will
have
have
s
s
equals,
equals,
and when
and
we
when we
integrate
integrate
this we
this,
will
we
have
will have
2
2
by
by
zero point
point
0.8
8
1 by
1 by
60
60
square
square
plus
plus
0.8
0.8
t
t
1 by
1 by
2.
2.
So
So
this
this
is
is
the
the
expression we
expression
will
we will
get.
get.
And the
And the
position at
position at
time t
time t
equals to
equals
4
to
will
4
be
will be
1 by
1 by
0.4
0.4
1 by
1 by
60
60
square
square
plus zero
plus
point 0.8
0.8
multiplied by
multiplied by
4
4
to the
to the
power
power
1 by
1 by
2.
2.
Here we
Here
will
we
have
will
1
have
by
1 by
60 as
60
well.
as well.
1 by
1 by
60
60
square.
square.
So
So
you will
you will
have
have
here
here
2.5
2.5
multiplied
multiplied
by,
by
so
So
here you
here
will
you will
get
get
position
position
at
at
time t
time t
equals
equals
4
4
will be
will be
4.43
4.43
meter.
meter.
So
So
basically
basically
we have
we have
used the
used the
same
same
concept here
concept here
in this
in this
question as
question
well.
as well.
It is
It is
just
just
we have
we have
given the
given the
acceleration this
acceleration this
time, and
time, and
this
this
acceleration is
acceleration is
variable. It
variable.
is
It is
not a
not a
constant
constant
because it
because it
is
is
depending
depending
on
on
the
the
velocity
velocity
v, which
v,
is
which is
itself
itself
changing
changing
with
with
respect to
respect to
time.
time.
So
So
here in
here
this
in this
question we have
question we
given
have
the
given the
acceleration
acceleration
and we
and we
need to
need to
find the
find the
velocity
velocity
and
and
position at
position
some
at some
specific time.
specific
So
time. So
again
again we will
we use
use
the
the
similar
similar
equation
equation
and
and
both time
both
we
time we
integrate to
integrate to
calculate the
calculate the
velocity
velocity
and
and
as well
as
as
well
the
as the
position
position
for a
for a
specific
specific
time.
time.
So
So
any
any
doubt in
doubt
this
in
one?
this one?
Not
Now
then we
then we
can
can
solve
solve
the
the
similar
similar
problem
problem
once
once
again
again
and
and
then we
then
will
we
move to
move
a
to a
little
little
different
different
one.
one.
So
So
here we
here
have
we
the
have the
acceleration of a
acceleration of a
point
point
A
A
is
is
defined by
defined
the
by the
relation A
relation A
equals
equals
minus zero
minus
point 0.8
0.8
sine
sine
kt,
kt,
where A
where
and
A and
T
T
are
are
expressed in
expressed in
meter per
meter per
second
second
square in
square in
second,
second,
and we
and
have
we have
given
given
K
K
as
as
3
3
rad per
rad per
second.
second,
Knowing
knowing
that
that
x
x
equals
equals
0
0
and v
and v
equals zero
equals
point
zero point
0.6
6
initially,
initially,
determine the
determine the
velocity and
velocity and
position
position
for a
for a
time
time
zero point 0.5
0.5
seconds.
seconds.
So
So
again this
again,
is a
this is a
similar
similar
problem
problem,
and we
and
have
we have
given the
given the
acceleration as
acceleration
well.
as well.
So
So
again we
again,
have
we have
to
to
repeat the
repeat the
process
process
actually.
actually.
So
So
we have
we
to
have to
integrate
integrate
twice. So
twice. So
first we
first
need
we
to
need to
integrate.
integrate.
So
So
first
first
we have
we have
given the
given the
velocity zero
velocity
point
point
0.6
6
and the
and the
initial
initial
position
position
0
0
at
at
time
time
equals
equals
0,
0,
and we
and we
need to
need to
find the
find the
velocity
velocity
and
and
position
position
at
at
time t
time t
equals zero
equals
point
zero point
0.5,
0.5,
and the
and the
acceleration is
acceleration is
minus
minus
1.8
1.8
sine
sine
kt.
kt.
Again we
Again,
will
we
be
will be
using
using
A
A
equals
equals
dv by
dv by
dt.
dt.
So
So
dv
dv
here
here
is
is
1.8
1.8
sine
sine
kt
kt
dt.
dt.
We are
We are
integrating
integrating
from
from
v0
v0
to v
to v
and
and
0 to
0
t.
to t.
So we
So
will
we
get
will
here
get here
v
v
minus
minus
v0
v naught
equals
equals
1.8
1.8
by
by
k
k
cos
cos
kt
kt
from
from
0 to
0 to
t,
t,
and it
and
will
it
be
will be
1.8
1.8
by
by
k
k
cos
cos
kt
kt
minus
minus
1,
1.
because if we
Because if we
put
put
0
0
here,
here,
the
the
cos
cos
kt will
kt
be
will be
1.
1.
So
So
this is
this is
my
my
v
v
minus
minus
v
v
naught.
naught.
So
So
v
v
equals
equals
v
v
naught
naught
plus
plus
1.8
1.8
and
and
k
k
is
is
3,
3,
and v
and v
naught is
naught
zero
is
point
zero point
0.6.
0.6.
Now I
Now I
need to
need to
find the
find the
velocity at
velocity at
time t
time t
equals
equals
0.5.
0.5.
So it
So
will
it
be
will be
cos
cos
3
3
multiplies
multiplies
0.5
0.5
minus
minus
1.
1.
So
So
here the
here the
velocity
velocity
will
will
be
be
0.599
0.599
meter
meter
per
per
second
second
at
at
time
time
equals zero
equals
point
zero point
0.5.
0.5.
And
And
then we
then we
can
can
write down
write
the
down the
velocity
velocity
expression
expression
as
as
rate of
rate of
change of
change of
position.
position.
So we
So
will
we will
get
get
here
here
ds
ds
equals
equals
v
v
dt
dt
And now
now
we
we
know the
know the
expression
expression
for
for
V.
V.
So
So
again on
again on
integrating,
integrating,
integration
integration
s
s
minus
minus
s
s
naught
naught
0.6
0.6
by
by
k
k
sine
sin
kt
kt
t
t
to
to
0.
0.
So it
So
will
it
give
will
you
give you
0.6 by
0.6 by
k
k
sine
sin
kt.
kt.
S naught
S
is
naught is
0,
0,
so it
so
will
it
be
will be
s
s
equals zero
equals
point 0.6
0.6
by
by
3
3
sine
sin
kt,
kt,
and the
and the
position
position
at
at
time
time
t
t
equals
equals
zero
zero
point
point
0.5
5
will be
will
zero
be
point 0.6
0.6
by
by
3
3
sine
sin
3
3
multiplied
multiplied
zero point
zero point
0.5.
0.5.
So
So
it
it
will
will
be
be
s
s
equals
equals
199.5
199.5
milliliter.
milliliter.
So this
So
is
this is
my
my
position at
position at
t
t
equals zero
equals
point
zero point
0.5,
0.5,
and this
and
is
this
the
is the
velocity at
velocity at
t
t
equals
equals
zero
zero
point
point
0.5.
0.5.
So
So
it
it
was
was
similar to
similar
the
to the
previous
previous
question.
question.
So
So
here
here
also we
also
are
we are
given the
given the
acceleration
acceleration
and we
and we
need to
need to
find the
find the
position and
position and
velocity
velocity
at a
at a
specific
specific
time,
time,
which is
which
zero
is zero
point
point
0.5
5
seconds.
seconds.
And
And
then we
then we
use
use
this
this
acceleration
acceleration
and
and
the
the
velocity
velocity
expression, and
expression
we
we
integrate
integrate
to
to
calculate the
calculate the
required
required
quantities
quantities
at a
at a
specific
specific
time.
time.
So
So
any
any
question
question
until
until
now?
now?
So
So
if
if
not,
not,
then
then
we
we
can
can
move
move
to
to
fifth
fifth
question
question
first,
first,
and
and
then
then
later
later
we
we
will
will
solve.
solve.
After
After
this,
this,
we
we
will
will
solve
solve
fourth
fourth
question.
question.
So
So
from
from
now
now
we
we
are
are
actually
actually
looking the
looking the
problems
problems
which
which
at a
at a
higher
higher
dimension.
dimension.
So
So
basically,
basically,
we
we
know
know
that
that
the
the
velocity
velocity
is
is
actually
actually
given
given
by
by
rate
rate
of
of
change
change
of
of
the
the
position
position
for the
for the
one
one
dimensional
dimensional
case,
case,
and the
and the
acceleration
acceleration
is
is
just the
just the
rate
rate
of
of
change of
change of
speed
speed
or the
or the
velocity.
velocity.
But
But
for the
for the
higher
higher
dimensional
dimensional
case,
case,
the
the
velocity
velocity
vector
vector
can
can
be
be
given
given
as
as
rate
rate
of
of
change
change
of
of
displacement,
displacement,
and the
and the
acceleration will
acceleration will
be
be
rate
rate
of
of
change
change
of
of
velocity
velocity
vector,
vector,
where
where
the
the
velocity
velocity
vector
vector
itself
itself
can be
can be
defined in
defined in
terms
terms
of
of
ux
ux
plus
plus
uy.
uy.
So here
So
I am
here I am
considering
considering
the
the
two-dimensional
two-dimensional
case,
case,
whereas
whereas
my
my
position
position
vector or
vector
the
or the
displacement
displacement
vector
vector
can be
can be
given
given
as
as
rx
rx
plus
plus
ry,
ry,
and my
and my
acceleration
acceleration
vector
vector
can be
can be
given
given
as
as
ax
ax
plus
plus
ay.
ay.
Now, if
Now,
I
if I
need to
need to
find
find
the
the
magnitude
magnitude
of
of
these
these
vectors,
vectors,
either
either
velocity
velocity
vector
vector
or the
or the
acceleration
acceleration
vector,
vector,
then I
then I
can
can
use
use
the
that
this
this
formula
formula
to
to
calculate the
calculate the
magnitude
magnitude
of
of
velocity
velocity
or
or
acceleration.
acceleration.
So
So
for a
for a
higher
higher
dimensional
dimensional
case,
case,
we have
we have
we
we
will
will
be
be
using
using
these
these
identities
identities
where
where
we have
we
to
have to
define
define
we
we
need to
need to
define the
define the
position
position
vector
vector
and the
and the
velocity
velocity
vector to
vector to
calculate the
calculate the
velocity and
velocity and
acceleration
acceleration
vector
vector
respectively.
respectively.
And in
And
order
in
to
order to
calculate the
calculate the
magnitude,
magnitude,
we
we
need to
need to
use
use
this
this
expression
expression
where
where
we
we
substitute the
substitute the
component of
component of
velocity
velocity
vector
vector
and
and
take
take
and
and
then
then
take the
take the
square
square
root
root
of
of
it.
it.
So
So
let's
let's
solve
solve
one
one
problem
problem
here.
here.
So here
Here
the
the
position of
position
a
of a
particle is
particle is
defined
defined
by
by
the
the
vector
vector
r.
r.
Okay. Is it
Is it
visible
visible
now?
now?
My
My
screen?
screen.
Okay then.
Okay then.
So
So
here the
here the
position of a
position of a
particle is
particle is
defined
defined
by
by
the
the
vector
vector
r.
r,
Where
where
the
the
t is
t
in
is in
seconds and
seconds
the
and the
arguments for
arguments
the
for the
sine
sine
cosine are
cosine are
given in
given in
radians.
radians.
Determine the
Determine the
magnitudes
magnitudes
of the
of the
velocity and
velocity and
acceleration at
acceleration at
time t
time t
equals
equals
1
1
second.
second.
Okay.
Okay.
So we
So
have
we have
given
given
the
the
position
position
vector
vector
r,
r,
which
which
is
is
pi
pi
cos
cos
2t
2t
or
or
sine
sine
2t.
2t.
And
And
we
we
need
need
to
to
calculate the
calculate the
velocity
velocity
and
and
the
the
acceleration.
acceleration.
So the
So the
velocity
velocity
will be
will be
given
given
as
as
the
the
rate
rate
of
of
change of
change of
position
position
vector
vector
by
by
dt.
dt.
Now
Now
both the
both the
component is
component is
actually a
actually a
function of
function of
time.
time.
So
So
here we
here we
can
can
directly
directly
take the
take the
derivative
derivative
of
of
both the
both the
components
components
and we
and
will
we will
get
get
minus
minus
10
10
sine
sine
2t
2t
plus
plus
8
8
cos
cos
2t.
2t.
So
So
now
now
this
this
is
is
my
my
velocity
velocity
vector.
vector.
After
After
taking the
taking the
derivative,
derivative,
this will
this
be
will be
my
my
velocity
velocity
vector.
vector.
And
And
velocity
velocity
vector
vector
at
at
time
time
t
t
equal
equal
1
1
will
will
be
be
minus
minus
10
10
sine
sine
2
2
8
8
cos
cos
2j.
2j.
So
So
it
it
will
will
be
be
minus
minus
9.09
9.09
vector
vector
plus
plus
minus
minus
3.3
3.3
to
to
j
j
cap.
cap.
So
So
this will
this
be
will be
my
my
velocity
velocity
vector
vector
at
at
time
time
t
t
equals
equals
1
1
second.
second.
And
And
similarly,
similarly,
now in
now in
order to
order to
calculate the
calculate the
velocity,
velocity,
magnitude of
magnitude of
velocity,
velocity,
we
we
will
will
have
have
vx
vx
square
square
plus
plus
vy
vy
square.
square.
So
So
this
this
is
is
my
my
vx
vx
component and
component
this
and
is
this
my
is my
vy.
vy.
So it
So
will
it
be
will be
v
v
square
square
plus
plus
2 3.32 square. So the magnitude of velocity will be 9.677 meter per second. And in the same way, we can actually define the acceleration vector, which is a derivative of the velocity vector, which is this. Sorry, which is this one. So it will be minus 20 cos 2t I component minus 16 sin 2t j. And the acceleration vector at time t equals 1 will be minus 20 cos 2 16 sin 2. So here we will get 8.32 1.54 g bar. This is my acceleration vector and time t equals 1. So my acceleration will be this is the magnitude of acceleration. Sorry, this is 14. So the magnitude will be 16.75 meter per second square. So just to recap, this time we have given the position vector and we need to find the acceleration and the velocity. So we use the standard expression, but since the position vector given in terms, it's a vector quantity, so we need to differentiate both the components separately and then substitute the time to calculate the component of those vectors separately. But if we need to calculate the magnitude, then we can use the standard identity to calculate the magnitude of any vector. So this relation is actually used to calculate the any vector. It doesn't mean that only for velocity acceleration vector you can use this relation. It is general relation to calculate the magnitude of any vector, given that you have already know the components of those vectors. And the standard general relation will be the same here. Only the difference is now it is a vector quantity. Is any question in this one? not,
not,
then we
then we
can
can
move to
move to
question
question
number
number
4.
4.
So
So
here
here
we
we
have
have
given
given
the
the
path of
path
a
of a
plane,
plane
which
which
is
is
described
described
by
by
this
this
equation:
equation
y
y
equals
equals
0.001
0.001
x
x
square.
square.
If
If
the
the
plane
plane
is
is
rising with
rising
a
with a
constant
constant
velocity of
velocity of
10
10
meter
meter
per
per
second,
second,
determine the
determine the
magnitude
magnitude
of
of
velocity and
velocity and
acceleration of
acceleration
the
of the
plane
plane
when
when
y
y
equals
equals
100
100
meter.
meter.
So
So
basically we
basically we
need
need
to
to
calculate
calculate
the
the
magnitude of
magnitude of
v and
V
a
and A
at
at
y
y
equals
equals
100
100
meter,
meter.
and we
And
have
we have
given
given
that
that
the
the
plane
plane
is
is
rising with
rising
a
with a
constant
constant
velocity of
velocity of
10
10
meter
meter
per
per
second.
second.
That
That
means
means
its
its
rising
rising
velocity
velocity
is
is
constant.
constant.
So
So
Vy
Vy
is
is
10
10
meter
meter
per
per
second,
second,
which is
which is
constant,
constant,
which
which
is
is
and
and
has a
has a
magnitude
magnitude
of
of
10.
10.
We
We
don't
don't
know
know
about
about
Vx,
Vx,
and
and
also
also
we
we
don't
don't
know
know
about
about
Ax.
Ax.
And
And
in
in
order to
order to
calculate
calculate
V and
V and
A,
A,
we
we
need
need
to
to
calculate
calculate
Vx,
Vx,
Ax,
Ax,
Ay,
Ay,
and
and
we
we
already
already
know
know
Vy
Vy
from the
from the
question.
question.
So
So
we
we
have
have
given
given
y
y
equals
equals
0.001
0.001
x
x
square.
square.
So
So
when
when
y
y
equals
equals
100
100
meter,
meter,
then we
then we
can
can
calculate
calculate
the
the
value of
value of
x
x
at
at
y
y
equals
equals
100
100
meter.
meter.
So it
So
will
it will
be
be
x
x
squared
squared
equals
equals
100
100
divided
divided
by
by
0.001.
0.001.
So
So
my
my
x
x
will
will
be
be
316.227
316.227
meter.
meter.
So
So
by the
by the
time
time
plane
plane
reach
reach
y
y
equals
equals
100
100
meter,
meter,
its
its
horizontal
horizontal
distance
distance
will
will
become
become
316.2
316.2
meter
meter
from
from
the
the
origin.
origin.
So
So
now
now
we
we
have
have
y,
y,
we
we
have
have
x,
x,
we
we
have
have
vy
vy
also,
also,
and we
and we
need to
need to
calculate
calculate
vx,
vx,
ax,
ax,
and
and
ay.
ay.
So we
So
can
we can
use
use
the
the
standard
standard
relation for
relation
the
for the
velocity,
velocity,
which
which
is
is
basically the
basically the
change of
change of
position with
position with
respect to
respect to
time.
time.
We have
We have
given
given
vy,
vy,
which
which
means
means
it
it
can be
can be
written
written
as
as
change of
change of
vertical
vertical
distance
distance
with
with
respect
respect
to
to
time,
time.
because
Because
it's
it's
a
a
vertical
vertical
component of
component
the
of the
velocity.
velocity.
So it
So
will
it
be
will
the
be the
rate of
rate of
change
change
of
of
vertical
vertical
distance
distance
divided
divided
by
by
time.
time.
And
And
we
we
know
know
y,
y,
which
which
is
is
0.001
0.001
x
x
square.
square.
Now
Now
x and
x and
y
y
is a
is a
is a
is a
function
function
of
of
time.
time.
I
I
mean
mean
both the
both the
distance.
distance
We
we
can
can
actually
actually
make
make
a
a
position
position
vector
vector
in
in
terms of
terms of
x
x
and y.
and y.
So
So
now
now
when we
when we
differentiate
differentiate
this,
this,
we
we
will
will
get
get
0.002
0.002
x
x
dx
dx
by
by
dt.
dt.
So
So
which is
which is
0.002 x,
0.002x,
and
and
this
this
dx
dx
by
by
dt
dt
is
is
actually
actually
my
my
dx.
dx.
So
So
vy
vy
equals
equals
0.002 x
0.002x
vx.
vx.
Now
Now
we
we
know
know
vy,
vy,
which
which
is
is
constant
constant
and
and
10
10
meter
meter
per
per
second,
second,
and we
and we
can
can
calculate
calculate
vx
vx
at
at
x
x
equals
equals
316,
316,
because
because
this is
this
the
is the
value
value
of
of
x
x
at
at
y
y
equals
equals
100
100
meter.
meter.
So
So
my
my
vy
vy
is
is
10
10
equals
equals
0.002
0.002
multiplied
multiplied
by
by
x
x
is
is
316.227
316.227
multiply
multiply
vx.
vx.
So
So
vx will
vx
be
will be
10
10
divided by
divided by
0.002
0.002
316.227.
316.227.
So my Vx is 15.8 to 2 meter per second, and this Vx is at x equals 316.2 and y equals 100. At this position, this is my Vx. Now we have Vx, we have Vy. We can now calculate the magnitude of velocity. And this magnitude is at this position, x and y. Vx is 15. 15.82. So my magnitude will be 18.715 meter per second. So this is the velocity magnitude at x 316.2 meter and y 100 meter. Now in the same way we can actually calculate the acceleration. So my vertical component of the acceleration will be rate of change of vertical component of velocity with respect to time, and this can be given as 0.002 x vx. Now both x and dx are actually depend on time. So in order to take this derivative, we can use the summation rule. So we will have 0. So I'm now writing the time derivative as, I'm indicating the time derivative by x dot or v dot or something like this. So it will be 0.002 x dot vx plus 0.002 v dot x. So x dot is actually vx. So it's 0.002 vx square, because this quantity is vx and this quantity is ax. That's 0.002 x ax. So I can write here as 0.002 vx square plus x ax. Now it is given in the question that the vertical velocity component Vy is not changing, it is a constant, which means that the acceleration in that direction should also be a constant, because acceleration is the rate of change of velocity, but the vertical component of velocity is not changing, which means the vertical component of acceleration should also not change. So which means that Vy should be 0, because Vy is constant. So this expression will become 0 equals 0.002 vx square plus ax. So which means vx square equals minus ax multiply x. So I can find the horizontal component of acceleration as vx square by x. We know vx. We already found the vx, which is this 15.822. And we need to find the magnitude of acceleration at y equals 100 meter. At this y, my x is 316.2 meters. So I will put this here. So ax will be 50. This is minus 10. 316. 0.7917 meter per second square. So now we have to find the magnitude of acceleration. We will have 0.7917 whole square plus 0, and the magnitude of acceleration will be then 0.7917 meter per second square. So this is my acceleration magnitude, and this is my velocity magnitude. So just to recap, we have given the trajectory of the airplane, which is given by y equals 0.001 x square, and we have given the vertical component of velocity as well, and it is said that it is a constant, and we need to find the magnitude of velocity and acceleration at y equals 100 meter. So first we found the corresponding x at y equals 100 meter, because there is a flight which is going, and this is my x distance, and when the plane reaches y equals 100 meter, it has some certain horizontal distance x, which is 316.2 meter, which we calculated here. Then after we get x, we know y, we also know vy. We actually use the general velocity relation to define the relationship between vy and vx. Then since we already know vy, we actually calculate vx from this relation, and now we know vx and vy, we can easily calculate the magnitude of a velocity vector, because we already know the component of velocity vector. Then we can easily calculate the magnitude also. Now for acceleration again, we use the general rate of change of velocity relation for the acceleration one, and we calculate the ax, acceleration in the horizontal direction. Now since vy is constant, the acceleration in the vertical direction should also be a constant, or should be 0, because there is no variation in the velocity, so the acceleration will be 0. So ay is just put 0 simply, and then we calculate the ax. Now the acceleration vector completely defined by only the horizontal component of acceleration. So whatever the magnitude of this acceleration, we will get the same magnitude of the overall vector. So my ax and my overall magnitude of acceleration will be the same. So any doubt in this question? If not, then we can move to the next question. So in this question, my objective is to show that the displacement and distance both are different quantities. So the displacement is actually a vector quantity, displacement is a vector quantity, whereas the distance is not a vector quantity, it is a scalar quantity, and both are different with each other. So in this question, we have a car travels from A to B and then from B to C. Determine the magnitude of displacement of the car and the distance traveled. So we need to determine the magnitude of displacement vector, and we know that A magnitude of displacement or any vector can be given by squaring its components. And then we need to calculate the total distance as well. So first we need to define this displacement vector. And from the figure you can see that in the horizontal direction it has the magnitude of 2 km. And in the vertical direction it has the magnitude of 3 km. So the displacement vector in the horizontal direction is 2. So let me define the coordinate first. So this is my positive x, this is my positive y, this is negative y, and this is negative x. And here it is defined in the direction of negative y. Because the car will turn right, it will turn in the direction of negative y from point B. And the magnitude is 3 km. So it will be minus 3j. So this is my displacement vector, and the magnitude will be given as which will be around 3.6 km. So this is the magnitude of displacement. Now to calculate the distance, we just need to add these two quantities. For example, first car moves from A to B, which is 2 km. So from here to here, car actually covers 2 km. Then from point B to point C, it covers additional 3 kilometers. So first it covers 2 km, then it covers 3 kilometers. So the distance will be 2 plus 3, which is 5 km. So here car covers the 5 kilometers, 2 km in the horizontal direction and then 3 km in the vertical direction. So the total distance covered by car is 5 km, whereas the displacement of a car is 3.6 km. So any doubt in this question? So this green region is actually representing the total distance which is traveled by the car, and this red line, this is the vector quantity which is actually representing the position vector or the displacement vector r. And this green shaded line is actually representing the distance. So any doubt here? So if not, then we can move to next question. So here we have a particle travels along the curve from A to B in 1 second. If it takes 3 seconds for it to go from A to C, determine its average velocity when it goes from B to C. So from A to B, it is given that particle will take 1 second. From here to here, particle take 1 second, and from A to C, it will take 3 seconds. That means to move from point A to point C, here it will take around 3 seconds. Then the time required from B to C will be 3 minus 1, 2 seconds. So from B to C, it will be taking 2 seconds. Because the overall the particle will take 3 seconds, and from A to B it will take 1 second, which means that the remaining time will be consumed by traveling from B to point C. So from B to C, the particle will take around 2 seconds. Now to calculate the average velocity, we will be using our standard formula, rate of change of position vector by time. So it will be vector r AC minus vector r AE, and it is delta t. So here delta time is 2 seconds. Now we need to define this vector RAC and vector RAB. So from figure we can actually easily define. So we know this distance is 20 meter. Because it's a radius of this semicircle, and this is also 20 meter. And this distance is again 20 meter. So the distance AC is 40 meter. So this displacement vector will be given as, so this displacement vector should give the displacement from point A to point C. So it should give a displacement from point A to point C. So at A I have a distance 0, 0, and at point C I have a distance 40, 0. So my displacement vector AC will be 40 I plus 0 j. And to define the displacement vector RAB, again we do the similar exercise, that at point A it is the position is 0, 0, and at point B the position is 20, 20, because it's 20 in y direction and 20 in x direction. So my position vector at AB is 20i plus 20j, and the position vector at AC is just 40i. Now we can use this relation. So it will be 40 I minus 20i plus 20j divided by 2. So we can subtract this x component from this x component. So it will be 20 I minus 20j by 2. So it will be 10 I minus 10j. So my average velocity vector is 10 I minus 10j. And in order to calculate the magnitude, we will have 10 square plus 10 square, which is root 200, which will be around 140, 14 something. So my magnitude will be around 14.14
14.14
meter
meter
per
per
second.
second.
So
So
this is
this
my
is my
magnitude
magnitude
and
and
this is
this is
my
my
velocity
velocity
vector.
vector.
So
So
here
here
also
also
based
based
on the
on the
figure,
figure,
we
we
actually
actually
determine
determine
the
the
position
position
vector,
vector,
which
which
is
is
you
you
can
can
easily
easily
determine
determine
from the
from the
initial
initial
position
position
and the
and the
final
final
position.
position.
And then
And
we
then
use
we use
this
this
standard
standard
relation to
relation to
find the
find the
velocity
velocity
vector
vector
and
and
the
the
magnitude of
magnitude
the
of the
velocity.
velocity.
So any doubt in this question? If not,
Now
then
then
we
we
can
can
move to
move
the
to the
next
next
question.
question.
So
So
now
now
from
from
this
this
question
question
we are
we are
actually
actually
trying
trying
to
to
solve the
solve the
question in
question
the
in a
curvilinear
curvilinear
motion.
motion.
So
So
before
before
begin
begin
solving
solving
the
the
question,
question,
let's
let's
recap
recap
some
some
fundamental
fundamental
concept in
concept
the
in the
curvilinear
curvilinear
motion.
motion.
So
So
basically in
basically
the
in the
curvilinear
curvilinear
motion we
motion, we
actually
actually
define the
define the
motion
motion
in
in
a
a
with
with
respect to
respect
the
to the
normal
normal
vector
vector
n
n
and the
and the
tangential
tangential
vector
vector
t.
t.
So
So
suppose we
suppose we
have a
have a
curve
curve
like
like
this.
this.
So the
So the
tangential
tangential
vector
vector
will
will
be
be
this
this
t
t,
and
and
this
this
will
will
be
be
my
my
normal
normal
vector.
vector.
And you
And you
can
can
actually
actually
define
define
these
these
two
two
set
set
of
of
vector
vector
anywhere
anywhere
in
in
this
this
curve.
curve.
So
So
the
the
rate
rate
of
of
change
change
of
of
direction of
direction of
these
these
two
two
vector
vector
will
will
actually
actually
trace
trace
out
out
the
the
whole
whole
curve
curve
here.
here.
So
So
now
now
we
we
need
need
to
to
define
define
the
the
velocity
velocity
vector
vector
and the
and the
acceleration
acceleration
vector
vector
in
in
terms
terms
so
so
that we
that
can
we can
easily
easily
calculate
calculate
the
the.
I mean
I
we
mean,
need
we
to
need to
define this
define this
expression in
expression in
terms of a
terms of a
curvilinear
curvilinear
coordinates.
coordinates.
So
So
for
for
that,
that,
let's
let's
say
say
here the
here the
basis
basis
vector
vector
is
is
En
En
and
and
Et,
Et,
and
and
let's say
let's say
there is
there
a
is a
curve
curve
here,
here,
okay,
okay,
and
and
and we
and we
need to
need to
move
move
to the
to the
another
another
point
point,
which
which
is
is
A
A
dash.
dash.
This is
This is
my
my
T
T
vector,
vector,
and
and
here
here
this
this
is
is
my
my
T
T
vector.
vector.
This
This
is
is
rho,
rho,
and
and
this
this
is
is
angle
angle
d
d
beta,
theta.
and
And
this
this
arc
arc
is
is,
let's
let's
say
say,
given
given
by
by
ds.
ds.
So
So
the
the
length
length
of
of
the
the
arc
arc
ds
ds
will
will
be
be
rho
rho
multiplied by
multiplied by
d
d
beta,
theta,
where d
where d
beta is
theta
the
is the
angle.
angle.
Now the
Now the
velocity
velocity
vector
vector
in the
in the
tangential
tangential
direction
direction
can be
can be
given
given
as
as
v,
v,
and
and
wait. So my
my
velocity
velocity
vector
vector
will be
will be
given
given
as
as
rate
rate
of
of
change
change
of
of
this
this
arc.
arc.
So
So
rate
rate
of
of
change
change
of
of
this
this
arc
arc
here
here
with
with
respect
respect
to
to
time,
time.
and
And
my
my
ds
ds
is
is
this
this
quantity.
quantity.
So
So
it
it
will
will
be
be
rho
rho
beta
beta
dot.
dot.
So
So
this is
this is
my
my
velocity
velocity
vector.
vector.
Sorry,
Sorry,
this is
this is
just a
just a
velocity.
velocity.
Now the
Now the
velocity
velocity
vector
vector
in the
in the
tangential
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 direction will
direction
be
will be
v.
v.
Sorry, it is
Sorry,
not
it's
a
not a
dot.
dot.
VET.
VET.
So
So
and my
and my
v
v
is
is
rho
rho
beta
beta
dot
dot
et.
et.
And
And
since
since
the
the
normal
normal
vector
vector
and the
and the
tangential
tangential
vector
vector
both
both
are
are
opposite
opposite
to
to
each
each
other,
other,
we
we
can
can
actually
actually
write
write
the
the
tangential
tangential
vector
vector
in
in
terms of
terms
a
of a
normal
normal
vector.
vector.
Now the acceleration will be given as change of velocity vector in terms of time. So it will be VET, or I can write this as, now I can use the summation rule to take the derivative here. So it will be V change of tangential vector plus V dot UT. So this is my acceleration vector. Now in this expression you can see that the acceleration not only depend on the magnitude but also depend on change of the tangential vector. Now it was not there in the Cartesian form, but in the curvilinear geometry we will get the rate of change of coordinate system plus, the acceleration depend on the rate of change of coordinate system plus the magnitude, the change of magnitude as well. So it is not just the change of magnitude of velocity, it is also a change of either of the direction in the coordinate system, which is E dot t. So we need to define this quantity, what is E dot t. So for example, let's say initially I have ET and it is get changed to E dash t. Okay, and this normal direction can be represented by En. And this is my d beta. And this quantity is d. The change in the tangential direction. So it will be d et equals to d beta En. And if I take the derivative with respect to time, it will be dEt by dt dB by dt En. So it will be E dot t equals to beta dot multiplied by En. So we already know the acceleration vector, which is E dot t plus V dot Et. Now we can use this the bottom relation, so we will get acceleration and we can also use, so we have given here B and we also know the magnitude of B, which is rho B dot. So this quantity is rho B dot. So when we substitute the above relation, this relation here, we will get acceleration as v square by rho En plus v dot Et. So this is my tangential component of acceleration and this is my normal component of acceleration. And the velocity vector can be completely given by this quantity. So in a unit circle, we can define the tangential component of acceleration as here AD in this direction, and this will be my
normal component of the acceleration.
and
And
this
this
will
will
be
be
my
my
velocity
velocity
direction
direction
also.
also.
So
So
my
my
tangential
tangential
acceleration will
acceleration
be
will be
v
v
dot
dot
or
or
r
r
theta
theta
double
double
dot.
dot.
My
My
normal
normal
component
component
will
will
be
be
v
v
squared
squared
by
by
rho,
rho,
or I
or I
can
can
write
write
in
in
terms
terms
of
of
r,
r,
so I
so
will
you
get
get
v
v
squared
squared
by
by
r.
r.
In
In
terms of
terms of
theta,
theta,
we
we
will
will
have
have
r
r
theta's
theta's
dot
dot
square,
square,
and the
and the
velocity
velocity
will
will
be
be
r
r
theta
theta
down.
down.
So
So
this
this
is
is
my
my
velocity,
velocity.
this
This
is
is
the
the
tangential
tangential
component of
component of
acceleration,
acceleration,
and
and
this is
this is
my
my
normal
normal
component
component
of
of
acceleration.
acceleration.
And we
And we
will be
will be
using
using
this
this
three
three
relation to
relation to
find
find
the
the
acceleration
acceleration
and
and
velocity
velocity
in
in
the
the
curvilinear
curvilinear
geometry.
geometry.
So
So
coming to
coming
the
to the
coming to
coming to
this
this
question,
question,
we
we
need to
need to
determine the
determine the
maximum
maximum
constant
constant
speed
speed
a
a
race
race
car
car
can
can
have
have
if the
if the
acceleration of
acceleration
the
of the
car
car
cannot
cannot
exceed
exceed
7.5
7.5
meter
meter
per
per
second
second
square
square
while
while
rounding a
rounding a
track
track
having a
having a
radius
radius
of
of
curvature
curvature
of
of
200
200
meter.
meter.
So
So
here
here
we
we
have
have
given
given
the
the
rho
rho
which
which
is
is
200
200
meter,
meter,
and we
and we
have
have
given
given
the
the
acceleration
acceleration
which
which
is
is
7.5
7.5
meter
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 per
per
second
second
square,
square,
and it
and
is
it is
said
said
that
that
the
the
speed
speed
is
is
constant.
constant.
Okay,
Okay,
so
so
if the
if the
speed is
speed is
constant,
constant,
which
which
means
means
this
this
component
component
of
of
acceleration will
acceleration will
be
be
vanished,
vanished,
and
and
we
we
will
will
have
have
only
only
this
this
component
component
of
of
acceleration.
acceleration.
So
So
this
this
will be
will be
0,
0,
and
and
only
only
this
this
is
is
not
not
0
0
because
because
speed
speed
is
is
constant.
constant.
So
So
v
v
dot
dot
equals
equals
to
to
0,
0,
which
which
means
means
the
the
tangential
tangential
component
component
of
of
acceleration will
acceleration
be
will be
0,
0,
and
and
we
we
will
will
have
have
the
a
normal
normal
component
component
of
of
acceleration
acceleration
which
which
will
will
be
be
v
v
square
square
by
by
rho,
rho,
and we
and we
have
have
given the
given the
acceleration
acceleration
7.5
7.5
equals
equals
v
v
square
square
by
by
rho,
rho,
and
and
v
v
square
square
will
will
be
be
7.5
7.5
multiplied
multiplied
by
by
rho
rho,
which
which
is
is
radius
radius
of
of
curvature,
curvature,
and it
and it
is
is
200
200
meter.
meter.
So
So
my
my
v
v
will
will
be
be
38.729
38.729
meter
meter
per
per
second.
second.
So
So
in
in
this
this
types
types
of
of
question, we
question, we
actually
actually
need to
need to
figure
figure
out
out
the
the
normal
normal
and
and
tangential
tangential
component
component
of
of
acceleration
acceleration
and
and
the
the
velocity,
velocity,
and
and
then we
then we
need to
need to
calculate the
calculate the
other
other
variables
variables
which
which
asked in
asks
the
in the
question.
question.
So
So
in
in
this
this
question, we
question,
have
we have
given the
given the
constant
constant
speed,
speed,
which
which
means
means
the
the
v
v
dot
dot
is
is
0
0
because the
because the
speed is
speed is
constant,
constant,
and
and
we
we
have
have
given the
given the
acceleration,
acceleration,
but
but
we
we
have
have
not
not
given
given
which
which
acceleration
acceleration
is
is
this.
this.
So
So
from the
from the
acceleration
acceleration
vector,
vector,
we
we
found
found
that
that
since
since
v
v
naught
naught
is
is
equals to
equals to
0,
0,
my
my
tangential
tangential
acceleration should
acceleration
be
should be
0,
0,
which
which
means
means
the
the
only
only
non-zero
non-zero
component of
component of
acceleration
acceleration
is
is
the
the
normal
normal
component
component
of
of
acceleration, which
acceleration, which
is
is
given by
given by
this
this
expression,
expression.
and this
And this
acceleration
acceleration
should be
should be
the
the
normal
normal
component of
component of
acceleration.
acceleration.
And we
And we
have
have
given
given
the
the
radius
radius
of
of
curvature
curvature
as
as
well.
well.
So
So
from
from
this
this
relation, we
relation, we
can
can
actually
actually
easily
easily
calculate
calculate
the
the
constant
constant
velocity,
velocity,
which
which
is
is
38.729
38.729
meter
meter
per
per
second.
second.
So
So
any
any
doubt?
doubt?
So let's move to the next question. So here we have a truck travels in a circular path having a radius of 50 meter. At a speed of v equals 4 meter per second. For a short distance from s equals 0, its speed is increased by v dot, which is 0.05 second uh, meter per second square. Determine its speed and magnitude of its acceleration when it has moved s equals 10 meters. So here we have given the speed v equals 4 meter per second, and we have given some acceleration, which is 0.05 s. And in the figure it is shown that the acceleration is in the tangential direction. So this is my tangential acceleration, and we need to find the speed and the magnitude of the acceleration at s equals 10 meter. So using the identity vdv equals 80 ds, where v dv is 0.05 s ds, and on integrating so here we will have v squared by 2 v from v naught to v equals 0.05 s squared by 2 from 0 to s. And s is 10, so we can write this as 10 square. And v naught is 4, so it will be v naught minus 8 equals 0.05 by 200, so it will be 5 by 2. So we will get v as 4.5 meter per second. Now the acceleration in the tangential direction is a 0.05 s. So my tangential acceleration will be 0.05 multiplied by 10. So 80 will be 0.5 meter per second. And the normal component is given by v squared by rho. We have given the rho, which is 50 meter, and v squared is this. we already calculated the v. So v square is 4.5 square. So my normal component of acceleration will be 0.405 meter per second square. So the magnitude of acceleration will be 80 square plus an square. So my magnitude of acceleration will be 0.643 meter per second square. And the speed is 4.5 meter per second. So just to recap, we have given the acceleration, and from the figure we identify that it is acceleration in the tangential direction. Then we use the relation that we saw at the beginning of this tutorial, and we found the velocity at s 10 meter, which is 4.5. Then to find the magnitude of acceleration, since we have already given the tangential direction, we need to find the component of normal acceleration as well. So for that we use this relation which we have saw, and by this relation we actually calculate the normal acceleration and then the overall magnitude of acceleration. So any doubt in this question? So move to the next one. So this question is actually the same question, similar kind of question that we saw. So here also we have given the tangential component of acceleration, which is given 0.5 e to the power t meter per second square. And we need to find the same quantities, the magnitude of acceleration. For that you need to find the normal component, and you already have given the tangential component, and then you need to find the velocity. So since you have given the acceleration here, so earlier the acceleration given in terms of the distance s, but now it is given in terms of time. So you can use dv by dt, and then dv equals a dt, and then integrate it to calculate the v, and you can easily calculate v, and then you can calculate v at time equal 2 seconds. And then to calculate the normal component of acceleration, you can use v square by rho. This rho is 5 meter, and you will get v square by 5, and you will get some magnitude of an. So it is the same question that we have solved. So you can do this question by yourself, and you can move ahead to the next question. So same question, just the expression here is different. Here it is given in terms of t. So you can use this relation, the acceleration, which is rate of change of velocity in time, to calculate the velocity. If the expression given in terms of some function which is s, then you can use the above relation like this, and you can integrate this relation to actually calculate the v. And if it is given in terms of time, then you can use this relation. And remaining things are same. You need to find the same quantities. So try to do this question by yourself, and we can move to the next one. So before solving this question, again, just to recap the formulae we have for the polar coordinates. So here the radial component of velocity, which is given by rate of change of r vector, sorry r, and the v theta is r theta dot. And the polar coordinates, you can actually write er dot as theta dot e theta, and you can write e theta dot as minus theta er. I'm just writing down all the formulae so that we can use in the problem. So the velocity can be given as r dot, and the r dot can be given as in terms of a vector quantity, it will be r dot er plus r er dot. Basically, you are taking the time derivative of this r. And you can use the above relation here to remove this er dot. So it will be r dot er plus theta dot r e theta. So this is my velocity vector. And using this same relation, you can actually get the acceleration vector, which is dv by dt. So you have to use the summation rule. So it will be r dot er dot plus r double dot er plus theta dot r dot e theta, theta double dot r e theta plus theta dot r e theta dot. So when you club and simplify this expression above, you will get r double dot r theta dot square plus r theta double dot plus 2r dot theta dot. So this will be your acceleration vector in the polar coordinate. So this is the radial component and this is the theta component of acceleration. Similarly, this is a radial component of velocity and this is a theta component. So we will be using these relations to calculate the acceleration and velocity vector. So in this question, we have a radar gun at O rotates with the angular velocity of theta dot, which is 0.1 rad per second, and angular acceleration of theta double dot, which is 0.025 rad per second square, at an instant of theta equals 45. As it follows the motion of the car traveling along the circular road having a radius of r 200 meter, determine the magnitudes of velocity and acceleration. So basically we need to calculate the VR, V theta, AR and A theta, and from that we can actually calculate the magnitude of velocity and acceleration. So from this vector we have given my VR is r dot and V theta is theta dot r, and in the equation we have given theta dot, which is 0.1, and we have given theta double dot, which is 0.025 radian per second square. So my v theta will be theta dot multiplied by r, which is 0.1 multiplied by 200. So my v theta will be 20 meter per second, whereas my r dot and r double dot is 0. So my vr will be 0. And similarly for the acceleration, this is my ar and this component is my a theta. So ar is r double dot minus r theta dot square, which is 0 minus 200 multiplied by theta dot square, which is 0.1 square. So my AR is minus 2 meter per second square, and my A theta is R theta double dot plus 2R dot theta dot. So this is 0 because R dot is 0, so it will be R theta double dot. R is 200 and theta double dot is 0.025. So my A theta is 5. So my magnitude of acceleration is 2 square 5 square, which is 4 plus 25, which is root 29. Which is basically 5.385 meter per second square. And the magnitude of velocity is 20 meter per second. So in all the equation of a polar coordinates, we need to find the component of velocity as well as the component of acceleration. Now, solving the similar kind of question here. So here we have a slotted link which is pinned at O as a result of constant angular velocity theta dot, which is 3 rad per second. It drives the back P for a short distance of a spiral guide R, which is given 0.4 theta. Determine the velocity and acceleration at R equal 0.5 meter. So we have given R, which is 0.4 theta. We have to find the acceleration and velocity at r 0.5 meter. So my theta will be 0.5 by 0.4. And also we have given theta dot, which is 3. So to find the velocity component, VR will be R dot. And my R is 0.4 theta, so my R dot will not be a 0 this time. So if I take the derivative with respect to time, it will be 0.4 theta dot. And we have given the theta dot, which is 3. So my R dot is 0.4 multiplied by 3, which is 1.2. So my radial component of velocity will be R dot, which is 1.2 meter per second. Now we need to find v theta, which is theta dot r. So we know theta dot, which is 3, and we know r, which is 0.5. So v theta is 1.5 meter per second. So my magnitude is 1.2 square plus 1.5 square. So my velocity is 1.92 meter per second. And in the same manner, we can actually find the component of acceleration. So my AR will be r double dot minus r theta dot square. So we have r, which is 0.4 theta, r dot, which is 0.4 theta dot, but theta dot is a constant, which means theta double dot will be 0, which makes r double dot 0, because theta dot is 3, which is a constant, and it is given in the question that a constant angular velocity theta dot. So theta double dot will be 0, because since the theta dot is constant, rate of change of theta dot will be 0. And r dot will be 0.4, sorry, r double dot will be 0.4 theta double dot, so it will, from theta dot double dot equals to 0, we will get r double dot equals to 0 as well. So it is 0 minus r theta dot square, so it will be minus, and r is 0.5, and theta dot is 3. So it will be minus 4.5 meter per second. This is my AR, and I can write A theta as r theta double dot plus 2r dot theta dot. So 0 plus 2. My r dot is 1.2, and theta dot is 3. So A theta will be 7.2 meter per second. So my acceleration will be 4.5 square plus 7.2 square. So my magnitude of acceleration will become 8.49 meter per second square. This is meter per second square. So this is my magnitude of acceleration, and this is my magnitude of velocity. So in both the question, we need to find the component of velocity and acceleration. That's all. So any doubt until now? So if not, then we can stop for today, and we can meet next week to discuss some problems related to the dynamics or the kinetics where we study about the force, and we will see how force actually change the velocity and acceleration and other motion in the system or for the particle. So, thank you. That's it for today.